Bismillahirrahmanirrahim. Let me complete this video. The recording is stopped because technical problem. Let's talk about the influence of gelation agent on the structure and microstructure of the final product. Like I said before, the microstructure is very important. Why? Because by increase the crystallinity and the grain size, the ferroelectricity properties will increase. That was my goal in my study. Now we will talk about the three important parameters: solvent, precursors, and agent. All of these, when increased or decreased, them ratio, the some change will be on the final product. However, while partial replacement of haloxide groups with gelating agent in the presence of the moderate amount of water, it's necessary because it acts like a medium, a reaction media, lead to slow condensation when partial replacement of haloxide happen. If haloxide groups are completely replaced, here it's a critical information because when it completely replaced, that's with gelating agent, sure. That's mean the we will not have hydrolysis and condensation process because they are will prevent it. However, gelates could form crystal structure. Now, let's talk about when a higher gelation agent to oxide ratio it's happened, but that's produced to us a small colloidal particles when higher. When small what will be when decrease this amount of gelation agent, the larger small particles will happen. When higher, small, when decrease this ratio, larger small particles will happen. That's mean reverse relation between the gelation agent with the particle size, small particle size. Beside particle size, it was established that gelating agent affect the shape of the final nanopowder and influence agglomeration and precipitation of the particle in the course of hydrolysis. That's mean here precipitation, that's mean cracks of the hydrolysis course. When particle size, it was established that gelating agent affect the shape of the final nanopowders and influence on all of the agglomeration and precipitation. As the ratio of gelating agent to oxide increased, the agglomeration decreased. Agglomeration decreased. I think that's not good because that when the gelation agent will be not high enough, that's mean the agglomeration ratio will increase. All my goal to make all the structure metal ion bonded together without cracks, increased the crystallinity and particle size of to the final product. All of that will act positively on ferroelectricity properties. Here, let's summarize all of these last two slides. Therefore, variation in gelate structure that make the gelation process very important. Variations in gelate structure affect on the process of the hydrolysis and condensation, the two stages of the salt gel process. The structure and microstructure of the obtained gel, that's very important to my topic. The structure and microstructure of the obtained gel. The crystallization process, let me not forget it. The crystallization process, phase formed, final properties of the material. By that, we have notes. In the course of thermal treatment, the organic phase is removed. Now I'm talking about when the foam shape, the dry gel is formed, and we try to evaporate to increase the temperature, to use simple evaporate by increasing the temperature step by step to reach 600 Celsius. All of that because we wanted to remove the organic phase to be sure. By that, the intensity of this process is controlled by thermal treatment regime and could greatly affect the texture, mixture, microstructure, and structure of the final material. These some pictures from my study from the lab when the sol gel is done, and I have the final product. It was black, like carbon. I used this mortar to crush the final product to be sure to eliminate the possible accumulation. I use this mortar to obtain a homogeneous mixture by crushing them. All these three pictures are clear. The mortar, I crushed, I put the final homogeneous product in the tube to be ready to the last step in the lab by using the pressure to press the powder to increase the distance between atoms and to produce tablets like that. I produced 18 tablets with different 18, yes, because at 1300 is they are melted. The last result was 12 tablets from them. Approximately the diameter was 1 centimeter, the width was 13 millimeters, something like that. These three sources, I depend on them to take the necessary information. You can take a look at them. Have a good day. See you in the next video.